And the last one, question 16. Looks quite a simple situation. Takes a bit of thought. I'm going to start with £500. We'll start with £500, but it's going to be in the bank for the whole year. And so by the end of the year, we've got £500 and the interest it's going to get, which is 1.035, 3.5%. Then in year 2, we're going to put the new £500 in, and that is going to get the 3.5%, which is that much. But you've also got this one here going for another year. So 1.035 squared. Looking at that, maybe trying another one again, we'll say that after 3 years, you'll have the original that's got 3 years worth of interest. You'll have this one here, which will now have 2 years worth of interest. And the new one you've just put in, which has got 1 year worth of interest. Notice that that's got a factor of 500. And so I've got 500 as a factor coming out of this. And this is a sequence 1.035 plus 1.035 squared, 1.035 cubed after 3 years. And if we're going for how many years? Well, that's the question, isn't it? 1.035 to the power of n. And what's n when this sequence here is 20,000? So I put equals 20,000. So I'm going to divide both sides by 500. If I divide by 500, I get 40. And this sequence here is first term 1.035, ratio 1.035, n is n that we're trying to find out. So I've got 1.035 r to the power of n minus 1 all over r minus 1. Right, I'm going to times that up there and divide that as well, leaving me 1.035 to the power of n, take away 1, I'm getting there 1.32 and a few extra bits. Add the 1 to both sides, and I've got 352. So 6570. And the last bit, take log to the base 1.035. So I'm getting n is 24.9 years, or about 25 years to save the total amount.